Welcome to this technical training presentation on the new Digitax HD range. The presentation covers the following topics: an overview of the different derivatives or versions, drive ratings and dimensions, the auxiliary components available for the drive range, power and control terminal configuration, EMC screening recommendations and internal filter disconnection, the rear venting or ultra-flow solution, multi-axis system sizing and kit assembly, the version of Connect required for Digitax HD, the location and content of technical data and documentation on Support Suite, and finally, the new design features incorporated with Digitax HD for improved reliability. Drag the timeline or navigation bar to the runtime shown to jump to a specific topic. Digitax HD utilizes functionality from the existing Unidrive M range. It uses the same firmware features, parameter functions, option modules and PC tools as Unidrive M. The firmware is almost identical to the existing M700 range with a few minor differences. Although the drive is branded as Digitax, it is also a universal drive, so configurable for AC induction motor control with the same open loop and RFC asynchronous modes as the existing Unidrive M range. There are 3 compact frame sizes up to 16 amps continuous current with a 48 amp peak, 300% overload capability. 200 volt single and 3-phase and 400 volt 3-phase versions are available. Terminal configurations allow for straightforward connection to common DC bus systems. The Digitax HD ratings are also aligned with the Unimotor HD ratings, and electronic nameplate data transfer will be available shortly. There are 4 main variants. The M753 EtherCAT drive has an integrated EtherCAT option and operates as an EtherCAT slave for centralized motion control applications. The EtherCAT module supports COE and EOE. EtherCAT drives are supplied with a factory-fitted compact display. The M751 base drive has an integrated RS485 communication module and is provided with a factory-fitted option module support for configuration flexibility, allowing a range of option modules to be connected as required. The M750 Ethernet drive has an integrated Ethernet module with multi-protocol support for Profinet, Ethernet IP and Modbus TCP. Module design and firmware is suitable for centralized or decentralized motion control. The M754 MCI version will include an integrated MCI module for decentralized motion control. This will also include multi-protocol support. As the firmware for each derivative is very similar to M700, each version includes onboard programming and AMC advanced motion control. Digitax HD is part of the high-performance drive range available from Control Techniques. Operating modes include V2F, open loop vector, closed loop vector RFCA, open loop permanent magnet motor control, and closed loop servo. A number of accessories are available for the Digitax HD range. EMC filters, both matched to individual inverter ratings, and an extended range up to 109 amps for single AC supply connection. Retrofit brackets to fit Digitax HD in place of Digitax ST, Unidrive SP0, Epsilon and Max. A KI compact display for drive status indication, resetting and node address or station alias setting. For direct DC supply, a cable grommet for up to 6mm cable connection and an external DC cable connection kit for between 6mm and 16mm cables. A side-mounted compact brake resistor, an encoder breakout module for direct cable connection to a sprung-loaded connector, a compact 485 adapter, particularly useful for commissioning with the M753 EtherCAT drive for PC tool connection using the CT communication lead, or connection to a KI remote display for easy parameter editing. An option module support kit which must be fitted to attach an SI option module, a range of standard length cables including a single cable solution for use with Control Techniques Dynamics motors, which includes motor power, feedback and motor brake cables in one, and available either unterminated or terminated with connectors at the drive end. The feedback cable is configured for NDAT 2.2 devices. Rear vent kits which allow heated air to be exhausted via the rear of the drive rather than the top. Model number description is very similar to Unidrive M, with a common format for derivative version, voltage and current rating. Note the optional build characters at the top right of the screen, which identify that M750 Ethernet and M753 EtherCAT versions include the KI compact display and no option module support as standard, whereas the M751 base version includes the option module support kit but no KI compact display as standard. Both the KI compact display and the option module support kit can be ordered separately, however. Headline ratings are given at a default switching frequency of 8 kHz and 40 degrees C ambient temperature. Peak ratings are listed with a 300% overload. Each drive rectifier is oversized to support multi-axis configurations, with one AC supply feeding multiple inverters via a common DC bus. Input power can be extended via a suitable line reactor. Three-phase peak current ratings are also available for single-phase applications, but from a lower nominal continuous current, however. Overload graphs illustrated in the Digitax HD installation and technical guide can be used to determine peak output current and duration. This slide demonstrates the 300% peak current duration. The curves are shown normalized to the drive nominal current rating in the x-axis and the overload period in the y-axis. The green curve represents 300% overload at 8 kHz switching frequency and 40 degrees C ambient. The blue line represents 300% overload at 8 kHz with the rear duct kit installed, and the red line represents 300% overload at 8 kHz switching frequency and 50 degrees C ambient temperature. If we use the 4.2 amp 400 volt frame 1 as an example, in a 40 degrees C ambient an output current of 4.2 amps will be represented by 1 on the x-axis. To determine how long the peak current of 12.6 amps could be maintained, we follow the green line along until it begins to deviate away from 1. At this point, we read off the time in the logarithmic scale. Although not immediately obvious in this slide, this occurs at 0.25 seconds. Therefore, when operating from the nominal current rating, a 300% peak overload can only be maintained for 0.25 seconds from the hot condition. The curves can also be used to determine the maximum nominal RMS current possible ahead of a fixed overload and duration. For instance, if a 300% overload of 12.6 amps is required for 4 seconds, the maximum RMS current will be 2.1 amps, which is 0.5 read off the x-axis multiplied by 4.2 amps. If a peak current of 12.6 amps is required for 8 seconds, the drive cannot produce any output current for at least 60 seconds prior to the overload. Or in other words, the overload is only available from the cold condition. These normalized curves can be used for all frames and both single and three-phase supplies. Similar curves are also available for 200% and 150% overloads in the Digitax HD installation and technical guide. Other output current ratings are available in the technical data section of the M75X installation and technical guide. These include open loop and RFCA operation, derating with the rear duct kit installed, output current derating when the cooling fan is limited to middle speed for noise sensitive applications, and output current derate for 0 Hz output frequency operation with no overload. As previously mentioned, the Digitax HD range has 3 frame sizes, each with varying height but with fixed width and depth. For drives not requiring option modules, without the option module support kit fitted, the product width is 40mm. For drives with the option module support kit fitted, the width increases to 62mm. Comparing the Digitax HD with the older generation Digitax ST, direct comparisons can be made with frames 1 and 2, where the output current is similar. Frame 3 extends the output current beyond Digitax ST and up to 16 amps nominal current. The smaller dimensions represent a significant reduction in volume compared to Digitax ST. Drive features from the top of the drive. AC supply and brake terminals are provided by pluggable connectors. Moving down the drive, we have the supply ground connection and DC terminals, the latter shown with the DC cover removed. Then we have 2 RJ45 communication ports and 2 external 24-volt supply terminals. Each Digitax HD must be provided with an external 24-volt supply. If this is removed, the drive will reset and power down. Dual terminals are provided so that the 24 volts can be easily paralleled if the drive forms part of a multi-axis system. A reset switch is provided with or without the compact display fitted. LEDs give the drive status condition and communication state. The compact display and our RS485 adapter are connected via a 6-way connector. The SD card slot is positioned to the right of the display. Control wiring is connected via a spring-loaded connector block. Feedback terminals are connected via a 15-way D-type connector. Motor terminals and ground connections are at the base of the drive. The following animation provides additional detail on the connector and SD card slots locations. Power connector layouts are shown in the diagram taken from the Digitax HD installation and technical guide. To connect an external DC supply directly to the drive terminals via a cable connection, unscrew the DC terminal cover using a T10 Torx driver and secure the cable crimp connections directly to the DC terminals with M4 screws. Cables up to 6 mm squared with M4 cable crimps can be connected directly to the DC terminals. One breakout tab, arrowed 1 in this slide, will need to be removed. To remove the tab, snip either side of the tab with a pair of wire cutters and twist the tab to remove it. DC cable grommet, CT part number 9500-1052, will need to be fitted when the breakout tab is removed. Grommets are not supplied in the drive kit bag and must be ordered separately. Breakout tabs do not need to be removed when using buzz bars included with the multi-axis kits. Only remove breakout tabs where required. An external DC bus cable connection kit can be fitted to accommodate larger cables between 6 mm squared and 16 mm squared. The kit is connected to the drive via 2 M4 screws and cables secured using 2 M5 nuts. The embedded video provides more information on DC supply cable connection. To gain access to the DC terminals, firstly ensure the drive is isolated from a power source and any power supply has been isolated for at least 10 minutes before the DC terminals are exposed. Undo the Torx slotted screw at the top of the DC terminal cover with a T10 Torx driver. Then the DC cover can be hinged down or removed. Check the DC bus terminal voltage is at a safe working potential with a multimeter before connecting cables or bus bars. For direct cable connection, remove one DC terminal cover breakout tab from the side of the DC terminal cover. To remove the breakout tab, cut either side with wire cutters, then remove by twisting with fingers or pliers. Note, breakout tabs do not need to be removed when connecting buzz bars from the Digitax HD multi-axis kits. Cables up to 6mm squared with a 4mm crimp can be connected directly to the DC terminals. This method of DC supply connection can be made from either the right or the left hand side of the drive. Slide cables through the DC cable grommet, CT part number 34700145, and push the grommet into position. Then attach the crimps to the DC terminals using two M4 screws and secure with a torque of 2 Nm or 17.7 pound-inches. Close the DC terminal cover and tighten to 1 Nm or 8.9 pound-inches. The cable grommet must be fitted to maintain the drive IP rating. Larger cables between 6mm squared and 16mm squared can be accommodated using the external DC bus cable connection kit. The external DC cable connection kit can be fitted to either the left or right hand side of the drive unless the SI option module support kit is fitted, when it should only be fitted to the left hand side of the drive. To attach the external DC bus cable connection kit, undo the torque slotted screw on the DC terminal cover, having already isolated the drive from a power source. Then check the DC terminal voltage. Break out one DC terminal cover tab, as previously shown. Attach the base assembly of the external DC bus cable connection kit to the DC bus bar terminals and secure with the two M4 screws supplied with the kit. Torque to 2 Nm or 17.7 pound-inches. Connect the DC cables to the terminal studs of the base assembly and secure with the M5 nuts provided. Tighten using an M8 socket and wrench to 4 Nm or 35 pound-inches. Slide the DC bus cable connection kit into position and secure the DC terminal cover. Tighten the DC terminal cover to 1 Nm or 8.9 pound-inches. An external 24 volt supply is required to power all the low voltage requirements within the drive. The 24 volt current demand will be in the region of 1 amp for the drive only in the run condition with the cooling fans turning at full speed. An additional 1 amp will also be demanded for 300 milliseconds when powering up with 24 volts. Current demand for other functions are also listed in the M75X installation and technical guide and need to be considered where relevant. Communication connections are the standard RJ45 layout for EtherCAT and RS485. The control terminals comprise of two safe torque-off inputs, one differential analog input, voltage mode only, with a maximum range of plus/minus 36 volts and a resolution of 11 bits plus sign, with a 250 microsecond update rate for the following parameters: 1.036 and 1.037 analog references, 3.022 hard speed reference, and 4.008 torque reference. The update rate for all other parameters, including all parameters when operating in open loop mode, is 4 milliseconds. Two digital inputs are configured for run forward and run reverse as default, with a 250 microsecond update rate for parameters 6.035 and 6.036 forward and reverse limit switch inputs. A 600 microsecond update rate is available for parameter 6.029 hardware enable, and a 2 millisecond update rate is available for in all other cases. 3 digital outputs are available. Digital output 1 is configured for at 0 speed as default, with a 100 milliamp output current limit or a 200 milliamp output current limit when combined with digital output 3. The update period is 2 milliseconds. Digital output 2 is a high motor brake output with a 1 amp capacity mapped to parameter 12.040 brake release. The update period is 2 milliseconds. Digital output 3 is configured as a 24 volt user output as default and can be switched to act as a third digital output. Nominal output current is limited to 100 milliamps or 200 milliamps when combined with digital output 1. A 2 millisecond update rate applies. Feedback terminal configuration is identical to M700 with the same P1, P2 feedback interface and encoder simulation output. The encoder breakout kit provides a quick cable connection method to a sprung-loaded connector rather than a soldered D-type connector. The cable screen should be connected to terminal 16. A 90-degree angled connector can be used for drives installed in a 200 mm deep enclosure. Internal EMC filters can be disconnected by removing the screw at the rear of the drive for frames 1 and 2 and at the bottom of the drive with frame 3. Cable screens should be bared back and cable tied to the cable screen bracket. Screens should not be terminated at the bracket and should continue up to the relevant connector. The pluggable connectors and cable screen bracket design make drive replacement straightforward where required. The same principle is also applied to frame 3, with a variation in the bracket design compared to frame 1 and 2. Key power and control technical data is summarized in this slide. 2 SI option module slots are provided with the Digitax HD, with option slot 1 corresponding to menu 15 at the top of the drive, and slot 2 corresponding to menu 16 lower down the drive. An SI option mounting kit must be fitted when connecting option modules. All standard M751 base drives are supplied with a factory-fitted SI option mounting kit. To install the SI option mounting kit, firstly remove the option slot covers using a terminal screwdriver. Only remove one cover if only one option module is to be fitted. Insert the option interface cards, taking care not to touch the gold contacts. The protective covers should not be removed at this stage. Note the interface card is intentionally positioned at an angle and will only fit one way round. Line up and clip the option module support frame to the drive. Remove the protective covers from the interface card, shown in stage 1 of this slide, Insert the SI option module tab into the slot on the drive plastic, shown in stage 2 of this slide, and push down at the rear of the module until it clicks into place, shown in stage 3 in this slide. This embedded video details how to attach the option module support kit. When connecting SI option modules, an additional SI option mounting kit is required if the drive is not supplied with an SI option mounting kit already fitted. To fit the kit, firstly insert a flat head terminal screwdriver underneath the option module slot covers and prise out in the direction shown. Install the interface cards into the option module slots. Do not remove the protective cover and observe the correct orientation. Note the interface card will remain at an angle with respect to the plastic. Care must be taken when handling the option module interface card to avoid contaminating the gold contacts. Gold contacts must not be touched directly. Only handle the interface card using the protective cover provided in the mounting kit. Line up and clip the option module support mounting frame to the drive in the direction shown. Remove the protective interface card covers. If only one option module slot is required, only remove one protective interface card cover. Align and insert the option module tab into the slot on the drive plastic. Once the option module tab is located into the slot on the drive, push down at the rear of the option module until it clicks into place. Note, once fitted, the SI option module remains at an angle with respect to the drive. This slide lists the option modules compatible with Digitax HD. Note, SI Applications Plus is not compatible, but can be directly substituted with SI Applications Compact. The KI Compact display provides drive status information via a single character display. It allows the drive node address or station alias to be set via dials on the front of the display and includes a recessed push button to reset the drive. All M753 EtherCAT models and M750 Ethernet models are supplied with a factory-fitted KI Compact display as standard. KI Compact displays can also be ordered separately. There are 5 single character indication codes that represent non-tripped inverter conditions. A tripped condition is characterized by the letter E followed by the trip code displayed one number at a time. Sub-trip codes are shown preceded by a hyphen, again one number at a time. Hardware faults are also displayed characterized by the letters H, then F, and then the fault code. Rotary dials allow for the node address on the M751 base model or station alias on the M753 EtherCAT model to be set with a value from 0 to 255. The most significant nibble is set by the top rotary dial, and the least significant nibble is set by the bottom rotary dial. Following a dial adjustment, the display will show the selected dial setting in hexadecimal, followed by the node address or station alias in decimal, separated with a hyphen. The station alias will be set to the sum of the most significant nibble and the least significant nibble. For example, To set a station alias of 55, set the most significant top dial to 3 or decimal 48 and the least significant dial to 7, decimal 7. Once the desired dial configurations have been set, the compact display will transfer the value to parameter 11017 keypad defined node address, and if the value is not 0, it will be updated as the station alias in the EtherCAT background. Where this is the case, any value in parameter 17035 configured station alias is ignored. The station alias setting can be configured for the rotary dials of the KI compact display with no power applied to the drive, with the exception of a 0 value setting. Non-zero configured settings will then be transferred to the drive on the next power up. A delay of 10 seconds should therefore be maintained following power up or following dial adjustment before the compact display can be removed from the drive to ensure correct transfer of station alias or node address configuration. Configuring the node address is identical to the station alias in that the rotary dial setting values are transferred to parameter 11017. Parameter 11023 serial address is also updated on the M751 variant, however. To connect the KI compact display to the drive, align the plastic tether on the display with a slot in the drive, shown in step 1 of this slide. Slide the display and the tether in the directions shown in step 2 towards the drive, and push the display until it clicks into position. The KI Compact 485 adapter provides a connection port to a KI remote keypad, which can then be used to view and edit parameters, or a temporary attachment for a PC tool connection such as Connect or CT Scope, for instance. The KI 485 adapter is particularly useful for initially setting up M753 EtherCAT and M750 Ethernet drives. This is a useful accessory when initially commissioning drives. The Compact 485 adapter can be fitted with the compact display tethered to the drive. Unclip the display and extend the tether and fold down the display. Then align the Compact 485 adapter and click into place. This embedded video details the functionality of the KI compact display and how to attach the KI Compact 485 adapter. The drive can be identified with a unique EtherCAT station alias or node address configured via the dials on the front of the KI compact display. The station alias or node address setting configured using the KI compact display is an 8-bit value or decimal 1 to 255. The most significant nibble is set by adjusting the top dial, and the least significant nibble is set by the bottom dial. The configured station alias or node address will be set to the sum of the most significant nibble and the least significant nibble in decimal. As the dials are adjusted, each setting is shown on the display. Once the dials are set to the desired configurations, the display will confirm the dial settings in hexadecimal, followed by the actual station alias or node address setting in decimal. The dial settings and station alias or node address settings are separated with a hyphen. Once the desired dial configurations have been set, the KI compact display will transfer the value to parameter 11017 keypad defined node address. For example, to set a node address of 55 via the display, set the most significant dial to 3 or decimal 48 and the least significant dial to 7 decimal 7. The station alias or node address can be configured from the rotary dials of the KI compact display with no power applied to the drive, with the exception of zero value settings. Non-zero configured settings will then be transferred to the drive on the next power up. The KI compact display can be installed or removed while the drive is powered. A delay of 10 seconds should be maintained following power up or following a dial adjustment before the compact display can be removed from the drive. This is to ensure the correct transfer of station alias or node address configuration data from the display to the drive. To install the KI remote keypad adapter, unclip and pull the display away from the front cover using a small terminal screwdriver. A slot in the drive plastic is provided for this purpose. The tether keeps the display associated to the drive. Align the remote keypad adapter with the display housing and install the remote keypad adapter over the display tether. Push the remote keypad adapter into the housing until it clicks into place. The remote keypad adapter can be removed by unclipping and pulling the adapter away from the front cover using a small terminal screwdriver. To reconnect the compact display, hinge the display upwards and click into position on the front of the drive. Each Digitax HD can be fitted with a drive-mounted compact brake resistor. The compact brake resistor has the same specification as the Digitax ST resistor. The resistor must be installed together with an SI option mounting kit. Multi-axis drives can still be connected directly side by side with one another, even with the compact resistor fitted. To install the compact brake resistor, first attach the SI option module mounting kit, step 1 in this slide. The resistor is secured with 2 M3 mounting screws and 1 M2 screw arrowed A in step 2. The M2 forms part of the thermal protection system and must be fitted. Finally, the cables should be connected to terminals BR1 and BR2 and cable tied to the bracket on the drive's metal housing as shown in step 3. This embedded video details how to install the compact brake resistor kit. The Digitax HD M75X series has been designed with an optional space-saving side-mounted brake resistor. The resistor must be installed together with the SI option module mounting kit. When the brake resistor is installed, an external thermal protection device is not required as the resistor is designed such that it will fail safely under any fault conditions. The inbuilt software overload protection is set up at default to protect this resistor. Secure the compact brake resistor assembly to the metal side panel using the 2 M3 mounting screws included in the kit and torque to 1 Newton meter or 8.9 pound-inches. Attach and secure the M2 screw with a maximum torque of 0.3 Newton meters or 2.7 pounds-inches. The M2 screw forms part of the thermal protection system for the compact brake resistor and therefore must be fitted. Connect the brake resistor cables to terminals BR1 and BR2 on the brake terminal connector. Secure the brake resistor cables to the metal side panel bracket. The ultraflow system or rear venting kit allows heated air to be exhausted from the rear of the enclosure via the rear of the drive rather than the top. This feature allows for a reduction in enclosure size, allows for vertical stacking of drives, and reduces the need for a secondary enclosure fan. One duct is required for frame 1 and 2 ducts for frame 2 and 3. The rear vent duct may be cut to size, or the drive may be aligned directly to a through hole in the rear panel of the enclosure, provided it is sufficiently well sealed. Heated air could then be exhausted between the enclosure backplate and the enclosure rear panel. To install the kit, attach the rear vent top cover to the top of the drive. Step 1. Align the rear duct tube with the exhaust port, ensuring the retaining clips on the tube are vertically aligned. Step 2. Click the tube into position. Step 3. A minimum clearance of 100 mm or 4 inches should be maintained between vertically stacked drives. Air can be exhausted via the enclosure backplate and rear panel, or drives can be aligned directly with a hole in the backplate without the need for a duct, which allows heated air to be expelled vertically between the enclosure backplate and the enclosure rear panel. An output current derating may need to be applied when the rear vent kit is installed. Deratings are listed in the technical data section of the Digitax HD installation and technical guide. Although the majority of drive losses are removed via the rear vent, some heat loss will remain within the enclosure. 75% of the heat losses will be expelled via the rear vent, with 25% remaining within the enclosure. For example, when calculating enclosure sizing for a 1.5 amp 400 volt frame 1 operating at 8 kHz switching frequency within a 40 degree ambient temperature, 22 watts will be expelled via the rear vent, with 7.4 remaining within the cubicle. The rear venting principles are shown in the following animation. Single axis or standalone drives should be mounted with 2 M5 screws in the top mounting position and 1 in the lower mounting position. For multi-axis mounting, A DIN rail attachment is provided for alignment at the rear of the drive. For multi-axis or side-by-side installation with no DIN rail attachment, one M5 screw is required in the top mounting position and one in the lower mounting position for each drive. For multi-axis installations with DIN rail attachment, one M5 screw in the top mounting is sufficient. Drives may be mounted side by side with zero spacing in between, but a 10mm gap should be provided between the enclosure sidewall and the drive. Multiple drive installations can be simplified using the Digitax HD multi-axis kits. Each kit comprises of the following: plus/minus DC and ground bus bars. These bus bars provide a quick method to interconnect the DC supply and supply ground terminals between drives. DC bus bars are rated for 60 amps continuous operation. 24-volt bus bar link. The link eliminates the requirement to individually wire a 24-volt DC supply to each drive. Up to 10 drives can be connected from one 24-volt power supply using these links. Communication link. This provides an easy connection between the integrated communication modules of each drive. Two multi-axis kits are available, one for drives with no SI option module mounting kit fitted, and the other for drives with an SI option mounting kit fitted. Each Digitax HD has an internal rectifier which has been designed to allow more output power than a single axis drive needs. This allows potentially up to 10 drives to be DC paralleled with a rectified supply from a single AC source without the requirement for DC fusing. The following embedded video details how to install the multi-axis kit. The Digitax HD terminal and enclosure design enables the DC bus, ground connection, 24-volt supply and communication ports of a number of drives to be connected together using pre-made bus bars and links to significantly reduce installation time and cost. Suitable bus bars and links for multi-axis paralleling are included in the multi-axis kits available as part of the Digitax HD installation and system accessories. Two multi-axis kits are available. Firstly for drives with no option module support kit fitted, and secondly for drives with option module support kits fitted. The installation method for either kit is the same. Undo the torque slotted screw on the DC terminal cover, having isolated the drive from any power source. Then check the DC bus terminal voltage is at a safe working potential. Attach the ground and DC terminal bus bars between the inverters with a T20 Torx driver and loosely fit all 6 M4 screws supplied with the kit. After fitting all screws, tighten to a torque of 2 Nm or 17.7 pound-inches. Multi-axis kit bus bars have a 60 amp rating. Close the DC terminal covers. Note, breakout tabs do not need to be removed when connecting bus bars from the Digitax HD multi-axis kits. Tighten the DC terminal covers with a torque of 1 Nm or 8.9 pound-inches. Connect the communication link between the inverters. Connect the 24-volt supply link between the inverters. A maximum of 10 inverters can be connected together using the 24-volt links. The example shown is the standard multi-axis kit where no option module support is fitted between the two inverters. Alternatively, the multi-axis kit for drives with option module support plastics fitted between the inverters includes longer bus bars and a longer 24-volt link. The installation methods for both kits are identical. Undo the torque slotted screws on the 3 DC terminal covers, having once again isolated the drive from any power source, and check the DC bus terminal voltage is at a safe working potential. Attach the longer ground and DC terminal bus bars between the inverters and again loosely fit all 6 M4 screws supplied with each kit with a T20 Torx driver. After fitting all screws, tighten to a torque of 2 Newton meters or 17.7 pounds-inches. Close the DC terminal covers. Note once again, breakout tabs do not need to be removed when connecting bus bars from the multi-axis kits. Tighten DC terminal covers with a torque of 1 Newton meter or 8.9 pound-inches. Connect the communication link and the longer 24-volt supply link between the 2 inverters. The following slides detail how to size a multi-axis Digitax HD system. This example consists of a 4-axis machine. Each axis is controlling a different torque profile, with the power and current requirements as listed in the table. The first step is to determine the individual power and sum total power for all axes. The second step is to select the most appropriate drive configuration to meet the demands of each power profile, and also to determine the worst case total system peak power demand. In this example, the worst case total system peak power demand for the profile is 9.6 kilowatts. The individual power and current profiles are used to size a Digitax HD for each axis. To reduce cost and installation time, multi-axis system drives can be DC paralleled with a single AC supply source to form a frame block. The peak output power demand and total DC bus capacitance of all the multi-axis drives are used to determine the size of the frame block and which drive can be used as the AC source for the frame block. In this example, the total system peak power demand is 9.6 kilowatts and the total DC bus capacitance for all drives is 980 microfarads. By comparing the worst case total system peak output power demand with the maximum continuous AC input power and the maximum frame block capacitance for each inverter, we can check whether any of the Digitax HD drives selected can also be used to act as the AC source for the frame block. The frame 3 is the largest drive in the proposed frame block, so we will begin by checking if it can act as the AC source. Frame 3 has an input power limit of 10 kilowatts or 13 kilowatts with a line reactor, which exceeds the 9.6 kilowatt peak requirement of the system. Its DC bus charging capacitance threshold of 2210 microfarads is above the system frame block capacitance of 980 microfarads. In the example, therefore, the frame 3 inverter can act as the AC source, as the maximum continuous input power is is greater than the peak output power demand, and the frame block capacitance is below the maximum charging capacitance threshold. Fusing will need to be provided in the branch circuit to the AC source drive. The input current for a given peak power can be determined using the formula given in this slide. The total system peak output power is used in conjunction with the constants listed by supply voltage and phase number to calculate the input current. Returning to the earlier example, a peak output power of 9.6 kilowatts results in an input current of 39.67 amps. When a Digitax HD is used as an AC supply for a frame block, only AC branch protection fuses are required. The maximum AC fuse current rating for all Digitax HD frames is 40 amps. As the input current remains within 40 amps in our example, no supplemental DC fuses are required, and 340 amp Bussmann LPJ Class J or Class GG fuses in the AC branch circuit would be sufficient to protect the frame block. In step 3, the external 24 volt supply and external EMC filter must be sized. The external 24 volt current demand for each inverter is listed in the electrical installation section of the Digitax HD series installation and technical guide. The current demand and input power listed for each drive and SI option modules must be summed to size the 24 volt supply, and an additional 1 amp per drive for 30 milliseconds following power up must also be allowed for. In the multi-axis system example, the total current demand will be 4.6 amps with an additional 4 amp peak inrush at power up for 30 milliseconds. The external EMC filter can also be sized using the peak output power formula. In the example multi-axis system, the 46 amp filter would be suitable. A list of external EMC filters is given in the technical data section of the Digitax HD series installation and technical guide. Digitax HD multi-axis kits can be selected for drives with or without SI option mounting kits fitted. In the example multi-axis system, Axis C and Axis D require SI option modules and Axis A and B do not. Therefore, the multi-axis kit requirement is split as shown in this slide. The maximum AC fuse rating for any of the Digitax HD frame sizes is 40 amps and either Class GG or Class J. Minimum ratings are also listed in the Digitax HD series installation and technical guide. When a frame block of Digitax HD inverters is fed from a DC source, the maximum fuse for any given block is 63 amps, with a maximum clearing I²T of 3.08 kA squared seconds. Alternatively, where a Digitax HD inverter needs to be individually fused, lower rated fuses can be fitted according to model. Where the DC input power is known, the following formula can be used to estimate the DC current with the option of selecting a smaller fuse if desired. The Digitax HD capacitor module provides additional DC bus capacitance which supports short-term mains loss ride-through by increasing the time to under voltage after mains loss. It reduces DC bus ripple when operating from a single phase supply, increasing the permissible output load capability of the drive, and it also helps absorb regenerative energy under motor deceleration. The capacitor module will be the same size as the Digitax HD Frame 1, with 725 microfarads per module for the 400 volt variant and 1740 microfarads per module for the 200 volt variant. Ground, DC bus and external 24 volt terminals are in the same position as the inverter to facilitate easy connection via multi-axis kits. Each Digitax HD capacitor module requires an external 24 volt DC supply for control and will have internal current inrush limitation, a status relay, status indication and thermal protection. Only Connect version 2.10 or later should be used with Digitax HD. Earlier versions will not recognize the drive. Support documentation, drawings, certification and firmware are available in the knowledge base section of Support Suite for the range of Digitax HD drives. This slide details the technical documentation available for the Digitax HD range. The Digitax HD series includes a number of design features incorporated to protect the product from reliability risks such as contamination due to particle ingress. This includes positioning surface mount and fine pitch components out of high airflow areas where possible. Circuits in areas of high airflow are conformally coated. Heatsink separation is maximised where required, and IGBTs are separated with baffles to protect components and provide a barrier between devices and heatsinks of different potential, whilst also guiding cooling air to heatsink fins. Control barriers have been added between power and control circuit boards, and cooling fan internal circuit boards are conformally coated and fans are easily replaced. Protected extra low voltage and safety circuits are separated from other circuits by barriers. Life testing of drives and cooling fans has been ongoing since the prototype stage, with many thousands of operational hours successfully completed. A conductive dust test was performed with carbon and cotton fibres to determine potential failure mechanisms. This test was conducted on all three frame sizes. No output devices failed as a result of the extensive contamination, which was sufficient to eventually clog and stop the cooling fans from turning. After extensive testing, only the frame 3 showed a voltage feedback error, which cleared after the drive was cleaned. The removal and refitting of cooling fans is a similar process across all three frame sizes. Firstly, the retaining clips should be pushed inward, step 1. This will allow the fan to be extracted. Disconnect the fan cable by prising the fan plug from the connector with a terminal screwdriver, as shown in step 2. Do not pull directly on the fan cables. When refitting the fan, ensure the airflow direction markings on the fan housing are positioned correctly. For further information on fan orientation, refer to the mechanical installation section of the Digitax HD installation and technical guide. Reattach the fan cable, slide the fan into position, and using a flat bladed tool, re-engage the retaining clips into position by splaying the clips outward. The Digitax HD range is TÜV approved and UL and CUL listed. In summary, the Digitax HD series offers a compact standalone high-performance range of drives with multi-axis capability that are easy and quick to install. Thank you. This concludes the Digitax HD technical training presentation.